Okay, so yeah, let's quickly write the remainder theorem. Remainder theorem. All right. Now here's the idea. If I just, I'll try and keep it as, well, as short and concise as possible. But essentially, given a polynomial function, and I'll just write f of x instead of writing, f of x equals to ax to the power of n, etc., etc. We'll just write f of x. The idea is the remainder obtained when we divide f of x by a linear of the type x minus c, and actually it's going to bug me, so let me say by a linear x minus c is equal to f of c. That's the theorem, okay? And I'll just quickly sort of showcase that with a very straight to the point example, I suppose. All right, so let me just write that here. I'll say example. There we go. So let's say I give you f of x. Well, actually, I'll write it like this. Find the remainder obtained when we divide. So I could make this sort of more formal, but I'll stick to this. Find the remainder obtained when we divide f of x, which equals to 2x cubed minus 5x squared plus 4x plus 3 by x minus 2, okay? And the x minus 2 we can write as such, or we could also write inside a pair of parentheses just to make it crystal clear that we're dividing the function by that whole thing. And now we basically have two ways of doing this so far. I mean, one way, according to the remainder theorem, first of all, what this is telling us is that if we were to divide this function by x minus 2, the remainder we'd get would just be equal to f of 2. So according to this theorem, that tells us that the remainder is equal to f of 2. Okay? Now, two ways of doing that. We could use synthetic division, or we could, of course, just evaluate f of x by replacing all the x's by 2. And I think I'll do that here. Actually, we'll do both. F of 2, well, that's equal to 2 times 2 cubed minus 5 times 2 squared plus 4 times 2 plus 3. If we now evaluate that, I mean, we have 2 times 2 cubed, which is 2 to the power 4, which is 16. Take away from that 5 times 2 squared, so that's 5 times 4, which is 20, plus 4 times 2, which is 8, plus 3. All right? So, like I often do, if I just add all the positives together first, 16 plus 8 is 24, plus 3 is 27. All right, so I've got 27, take away 20. The remainder we get is 7. Okay? So f of 2 equals to 7, and hopefully the theorem is understood. That tells us that's the remainder of f of x divided by x minus 2. The way that we've already seen, but we didn't really I didn't emphasize the fact that we had the remainder on the far right-hand side. The second way that we have, of course, is synthetic division. Okay, so if I were to write the coefficients of my cubic polynomial, we have 2, negative 5, 4, and 3. If I were to write those at the top of the table, 2, negative 5, 4, and 3, and I'm evaluating this at 2, right, because it's x minus 2, so according to the remainder theorem, I'd evaluate it at 2. So if I write the 2 on the far left-hand side of that table, I drag down the 2, that's the leading coefficient, and now I get started. So I'll have 2 times 2, which is 4, which I write in the next column. I add that 4 to the negative 5 above it, which gives us negative 1. I'll then have 2 times negative 1, which is negative 2. I add that negative 2 to the 4 that's above it, so 4 plus negative 2, which is 2. And finally, 2 times 2, which is 4. I write that in the next column, and I add the 3 that's above it, which is 7, right? This 7, that's the remainder we obtain when dividing f of x by x minus 2. While we're here, remember that we had also seen that the coefficients that we obtain to the left of that remainder are the coefficients of the quotient polynomial we get when we divide f of x by x minus 2 in this case. In other words, those coefficients tell us that when we divide f of x by x minus 2, we get the quotient 2x squared minus 1x, so minus x plus 2. So I could even go as far as saying f of x divided by x minus 2 equals to 2x squared minus x plus 2 plus 7, that's the remainder, over x minus 2. Okay, so as such, it's nothing really new to us because we had already seen synthetic division, but we hadn't formally written the remainder theorem in our notes.